Alrighty, let's analyze this ideal transformer circuit using ideal transformer relationships that we know to be, for example, or to start with, we know that the ratio of V2 over V1 is equal to N2 over N1. We know that N1I1 is equal to N2I2, and the third of them is that the reflected impedance, or the resistance looking into the primary, call it Rn. Rn is equal to N1 over N2 squared times R sub L. Alrighty, and we want to find the currents I1 and I2. We want to determine what the voltages V1 and V2 are. We want to show that the power into the transformer equals the power out of the transformer. Well, this one gives us a little bit of a twist here because we've got this 50 ohm resistor in series with the primary winding. So in this case, we can't simply say that V1 equals the 20 volt source. What we can say, though, is that V1 is equal to 20 minus the drop across the 50 ohm resistor. And of course, the drop across the 50 ohm resistor is going to be I1 times 50. So how do we go about getting I1? Well, we know that there is an equivalent resistance that this seen looking into the primary, and that equivalent resistance in series with the 50 ohm resistor is what that 20 volt source sees. So let's determine what the reflected resistance is, and then we can calculate I1. I1 will simply be 20 divided by the 50 plus Rn. So Rn, using that formula right there, we have Rn is equal to N1 over N2. Well, let's see, we need to know the turns ratios here. We got 5 turns on the primary for every 1 turn on the secondary. So it'll be 5 over 1 squared times 8. Well, 5 squared is 25 times 8. That's 200 ohms. Therefore, I1 is going to equal 20 divided by 50 plus Rn, which is 20 divided by 50 plus 200. That gives us 0.08 amps. Now, right then, we could go ahead and calculate I2. In fact, let's just go ahead and do that. Let's go on over here and say then that I2 is equal to N1 over N2 times I1. Is that right? Which is N1 over N2, that's 5, times I1 is 0.08. 5 times 0.08. 5 times 0.08 is 0.4 amps. Alrighty, now let's go ahead and calculate what V1 is, because we know that, now that we know I1 is 0.08 amps, we can calculate V1. V1 is then equal to 20 minus I1, which is 0.08 times 50, and that equals, let's see here, 8 times 5 is 40. So 0.08 times 50 is 4 volts, and 20 minus 4 is 16 volts. Alright, we now know I1 and V1. Let's just, while we're at it, let's go ahead and calculate V2 using our relationship here. V2 is equal to N2 over N1 times V1. Well, N2 is 1, N1 is 5, V1 is 16. That equals 3.2 volts. Alrighty, so we have I1 and V1 and I2 and V2. Let's just show now that the power into the transformer has got to equal the power out of the transformer, or V1 I1 has got to equal V2 I2. Well, V1 we found to be 16 volts times I1 was 0.08 amps. And that's got to equal over here on the other side V2, which is 3.2 volts, times I2, which we found to be 0.4. And on the left side, we've got 18 times 0.08 That's 1.26 watts. And on, I guess we ought to be saying, we're wanting to show this. Does 1.26 watts equal, let's see, 3.2 times 0.4 is 1.26, that's not 1.26, it's 1.28 watts. And over here we have 3.2 times 0.4, that is also 1.28 watts. So, yep. Power in equals power out. And again, what did we do here? That 50 ohm resistor made it so that we had to calculate the input resistance using the equivalent resistance reflected back through the transformer.